Today on Robot Rivals, two colleges will design and build robots from scratch in only one day. When the time is up, they'll square off in a head-to-head competition on their quest to become the Robot Rivals champions. Hi everybody, welcome to Robot Rivals. I'm your host, Chris Chianelli. Our competition pits college students from all over the country against each other to see who can build the very best robots. And I know what you might be thinking, build robots? Just a few short decades ago, robots existed only in the world of science fiction. Today, robots are all around us. They're used to build cars, explore space, detonate explosive devices, and even help in hospitals. In recent years, robot building has been transplanted out of the laboratory and into homes across the country. Robot building clubs, competitions, and websites are all over the place. You'll find robotics in mall electronics stores, and you can even go to popular bookstore chains and find robot building kits right next to your favorite novel. So, if high-tech how-to is your thing, you're gonna love Robot Rivals. Today's matchup pits Virginia Tech against Georgia Tech in a head-to-head competition. Based on random selection, today's winner will get a bid to the third round. And here they are, the Yellow Jackets of Georgia Tech. Come on.
Daniel Schaefer, Junior, Computer Science.
Kyle Howell, Senior, Computer Engineering.
Stephen Steppes, Graduate Student, Aerospace Engineering.
Let's welcome your robot rivals, the Virginia Tech Hokies!
Yeah, man, let's build some robots, guys. You ready to do it? Let's go. All right, let's do it.
Chris Towalt, Master Student, Mechanical Engineering.
Ian Hovey, Senior, Mechanical Engineering.
Graham Henshaw, Master Student, Mechanical Engineering.
Welcome to the show, guys. Good to have you here.
See you, Chris.
What's up? Okay, before today, you guys all received a package of all the information you'll need to complete the challenge at hand, right?
That's right.
Let's take a look at the specifics of your task. Today's teams must design and build a radio-controlled robot that can move and locate a soccer ball, grasp, contain, and/or corral the soccer ball, and propel the soccer ball over a specified distance into the goal. During the design process, we'll give our schools a surprise household item to incorporate into their robot. The team that uses the most functional parts will receive a 10-second head start in the competition. All right, guys, I know it sounds like a lot of work, but never fear. Our experts are here to help you out. Working today with Georgia Tech is Brian Neve. He'll lend his expertise from multiple engineering degrees and years of television robotic competitions. Joining Brian and working with Virginia Tech is Buzz Dawson, an engineer for the NASA Kennedy Space Center and mentor to youth robotic teams across the country. All right, teams, you've got your assignment. You've got your experts, you've got your materials. The day starts now, so get to those design boards and start building those robots.
That's right.
The teams are geared up and ready to go. We'll see if they have what it takes to win today's competition. All right, this is it. We're ready to roll. The teams are ready to roll. They got all their stuff. Let's go take a look at some of their preliminary designs.
6. That's going to be about 2 miles an hour. What do you guys think about 2 miles an hour?
2 miles an hour.
2 miles an hour.
It is.
You want to shoot for around 8 to 10 miles an hour. That's a controllable speed. Any faster than that, it's just going to be all over the place.
Okay, so if this
Before the teams get too far into their planning, I've stopped in to give them a sample of what they'll be using in the competition. Here's your soccer ball. So you know the surfaces you'll be working with, and that's the surface you'll be running on. Both teams seem calm and collected as they adjust their design to the soccer ball size and the playing surface. Georgia Tech may have time for fun and games now, but the day goes by quickly here on Robot Rivals.
I think the next biggest issue that we need to overcome is how we're going to get this ball in
and how we're going to shoot it out. And so one of the ideas was the conveyor belt idea. And so we have a conveyor belt that runs all the way across. We drive up to a ball, just drive right into it. The conveyor belt, since it's rotating, would pull it inside, pull the ball inside.
It looks as if both Virginia Tech and Georgia Tech are off to a great start. As our teams continue working through their ideas, Buzz and Brian make sure the parts are ready for the construction and the shelves are stocked with everything they'll need and more. Don't go away. Motors, metal, nuts, and bolts transform into soccer-playing robots. But not before we throw one last surprise into the mix. Today's robot rivals from Georgia Tech and Virginia Tech have a challenging task to conquer, but that's only the beginning. They're up against top engineering schools from all around the country who are competing for the Robot Rivals Championship and a shot at a $2,000 scholarship, not to mention a place on the coveted J.F. Engelberger Trophy.
Well, guys, this thing looks pretty good here. Say, it'll be two-wheel drive, and what, we'll be pulling them in with these wheels here to pull them up inside of it?
That's exactly right. Yeah, these are going to drive.
Before our schools finalize their designs, we're going to throw a twist into the process. On every Robot Rivals, we give the teams a surprise household item, items that can be found in almost every home or office. No matter what we give them, the students will be challenged to incorporate everyday parts into their high-tech robots.
That's the way to go. But I'm not sure if you guys have remembered the super secret household item.
Yeah.
What we have right here is your basic 1960s era decrepit old beat up sewing machine.
Feast your eyes on that dandy little baby right there.
Wow. Yeah, that's old.
Incorporating the sewing machine into their design won't be an easy task. Virginia Tech plans on building a box-shaped robot with 2 main drive wheels and 2 gripper wheels on the front. Once the ball is located, the wheels will grab the ball and bring it inside the robot. After driving to the goal, they'll then be reversed and the ball will be propelled forward. Georgia Tech also seems confident they can use the sewing machine in their design. After building a simple drivetrain, which includes 2 wheels attached to a metal frame, Georgia Tech will then decide on a shooting mechanism later in the day. We'll have to see if the indirect design approach helps them save time. Let's see how Chris and Ian from Virginia Tech are coming along with the Hokie shooter mechanism.
Our motors had relatively short leads on them, and we want to be able to hang on to this thing and do a test to make sure that the soccer ball can be propelled at a high enough velocity. So right now Chris is soldering on another wire along with a terminal that'll allow us to directly plug the battery into the motor and operate it for a short time to perform our little test.
One of the most common reasons for robot failure is improper wiring of the robot. Now, the wiring of the robot is very much like the human nervous system. You have a brain that wants to send electrical signals down to the other parts of the robot and get information back, and it needs to do that through wires. Very much like in this video game controller, on the back of it we have all the wires and interconnects. The common way of connecting wires within a robot is to use solder, and solder is a mixture of lead and tin. Now, don't forget to use your safety goggles when you're doing this. What we're going to do first is we're going to actually what's called tinning the wire, which is get a little bit of the solder onto the wire first so that it goes onto the circuit board a lot nicer and quicker. Now, once we have that done, we'd actually put it onto the circuit board and solder it right to the circuit board, and we have a nice, solid, tight connection that will conduct electricity and won't fail on us.
While Stephen and Brian calculate the Georgia Tech design, Daniel dives into the sewing machine.
I've actually never even taken one of these things apart. I've taken lots of stuff apart before, but not a sewing machine. The first thing I tore apart was a remote control car, and I couldn't get it back together, so I started building different new things out of it. And after that, I started taking things apart specifically to use pieces of them. Some nice switches there, some control knobs. bunch of nice little gears and stuff. Not quite sure how we're going to use it yet.
Daniel seems a little unsure about using the sewing machine in Georgia Tech's robot. Let's see if the Hokies are having similar problems.
I see you're getting into the household surprise item here.
Yeah, I am. I'm trying to find some parts so that we can collect the 10-second head start.
I see stuff here which I've seen on robots.
Right here we have a belt drive system, and this is coupled to a motor down here, which every robot needs to have.
And you got what else you got on it that you're looking at?
There's a shaft. There's shafts that run various places throughout the whole thing.
Right here.
But right here's an example of one.
We got these heavy-duty helical cut gears, and over here we've got the bevel cut gears. So you're taking a look at some of the systems on the sewing machine.
Yep, and trying to get an idea for what I can use.
All right,
So.
keep up the good work. Look at all this cool stuff here, all these pre-assembled components. You have motors with right-angle drives, probably a worm gear setup, and pre-assembled electronic components. Brian, to get this stuff, can anybody get it, or do you have to be, you know, a member of the secret society of robot builders to get it?
Well, you know, it used to be kind of a closed society, and only movie special effects guys could get this stuff easily. But now, with the internet, you can go online anywhere. NPC Robotics, Team Delta, get your electronics, get your motors, anything you want, it's delivered right to your home.
Anyone can go get it if they go there.
Anybody can go get it.
Great. For more information on anything you've seen here or anything else on the show, just go to our website, DIYnet.com. It's lots of cool stuff there. Thanks a lot, Brian.
Hey, my pleasure, Kristen.
Coming up next on Robot Rivals, one school focuses on their propulsion device, while the other tackles their drivetrain motor housing. Which strategy will pay off in the competition? We'll find out.
Sometimes the world changes us. Sometimes we help change the world. Shaping futures through innovation. Georgia Tech.
On today's Robot Rivals, our teams of mechanical engineering students from Virginia Tech and Georgia Tech were given the task of building a robot that could play soccer. Out of only the parts and pieces we give them, they'll have to come up with a working robot before the day is finished and the competition begins. Virginia Tech is really moving. Before they get too far along, they want to test their propulsion device. They've taken two 6-inch rubber wheels and mounted them to a pre-assembled right-angle drive motor. After temporarily attaching the launch mechanism to a piece of scrap metal, it's time to see if it works.
Sweet.
Now that Virginia Tech knows the gripper wheels will shoot the ball, they regroup and test out the containment area. Using a piece of 1/8-inch sheet aluminum bent into a circular ramp, the trap ball will be held in place until they reverse the motors and shoot it into the goal. If there's time, they plan on adding side rails for additional support. Over on the Georgia Tech side, Kyle is working on the drivetrain motor housing. He's cut two pieces of steel angle iron and attached them to two main drive motors that Brian helped select from our fully stocked shelves. This will become the base frame for the wheels, the electronics, and additional components.
Okay, so as we can see, this isn't quite going to keep our wheels the way we want them to. So what we're going to do is turn some triangles by putting cross beams in across here and here. We just need to find the right holes to bolt them into. And hopefully that will keep this guy from turning.
To begin the frame assembly of the Virginia Tech robot, Graham has cut two 10-inch pieces of extruded aluminum and attached them to a set of combined wheels and motors.
All right, so what I'm doing here is making our frame system for our drive motors, our two wheels here. This is our basic setup for our robot. We're going to have differential steering. And so this is how we're connected our two motors together, just using this extruded aluminum that we had in the lab here. So we're going to use this for the rest of the frame too, and we'll just join them with these pieces that are going to go in here, and we'll have more aluminum frame that'll run out and form the rest of our robot.
Back over on the Georgia Tech side, Kyle finishes the drivetrain cross braces, then attaches the wheels to the motors with half-inch galvanized bolts and washers.
Everything's coming along good.
Yeah.
We busted up everything into modular components so that we could build them separately.
Smart, smart.
We got the drive going on over here. We're going to get it running, get it driving, get the guy practicing driving. And we got the ball chucker going on over there. So we can test them separately, run them separately, build them separately.
That's a good thing about the modular approach, is they don't get the thing all done and then find out if all the systems work. You build this part of the system, find out if it works, and you're building another part, the retrieval and launching system. Way to work.
Thanks, Chris.
All right. It looks really good.
Thanks a lot, Chris.
Okay.
See ya.
Georgia Tech's modular building plan could definitely save on time, but only if the components work properly and get finished together.
This is the AC motor that came from the sewing machine. Because it runs on alternating current, which you get out of your household socket in the wall, we can't use it for this because we're using batteries, which is direct current. But we're going to use the switch as well as maybe some of the connectors and wires, and maybe this pulley here for the belt.
Wow, Virginia Tech is really concentrating on winning that 10-second head start.
So you want to start driving now?
Just start pulling.
Well, we can with duct tape. But we can't.
Even when you're building a robot, improvisation is the key to getting the job done. In order to save time, Georgia Tech has decided to duct tape their front wheels on. It's a good temporary fix, but they'll have to take the time out later to bolt them together for the competition.
Well, one of the most important things in building a robot is actually getting the power to the motors. Now, there's lots of ways to store power in batteries, and we use batteries in robots. You got this gigantic battery like you'd use in your boat or your car, and it has a huge amount of power. Now, you got these little tiny batteries that you put in your radio, and they don't have quite so much power. Now, in robots, we use this battery, which is kind of the middle of the road. It's a NiCad pack, but it actually can source a lot of current for its size. It has a high current density. Now, current is really important in power, and to get a lot of current, you need a big fat wire. A little teeny skinny wire can't conduct enough current because it has too much resistance. And a big fat wire, you can think of that as kind of like a pipe. The bigger and fatter the pipe is, the more water can flow through it easier. Now, for more information about current and power, check out our website, DIYnet.com.
All right, right now I'm putting some threads in the end of this extruded tubing. It just so happens that the hole that is already in the end of the tubing is the right size that we can tap it. And it's aluminum, so it's pretty soft and easy to do. But basically, you just take this tap, put it on this handle here, and take one turn in and then half a turn back, and that helps clear out the shavings. Normally, you put some kind of oil on there, but I'm getting away with not because it's aluminum, so.
The Georgia Tech Yellow Jackets are sticking to their divide-and-conquer approach to robot building. While Brian and Kyle work on the wiring, Stephen works on the firing mechanism. He's attaching a pre-assembled motor and axle setup to the front half of the extruded aluminum. Much like the Virginia Tech design, he then adds gripping wheels to the frame and a chain drive connected to the motor. It seems that form follows function, but the question still remains, will they have enough time to finish their robot? Coming up next on Robot Rivals, things take a turn for the worst as miscommunication stings the Yellow Jackets, while Virginia Tech keeps trucking along on their wiring system.
Rapid virus detection.
Creating a better way to make certain our water is safe.
Step-loaded helix antenna.
Expanding the reach of high-speed wireless technology.
Preeclampsia diagnostic method.
Making birth safer for mothers and infants.
3D holographic microscope.
Finding a way to see deeper inside our world. In the lab, the classroom, the world we live in. Virginia Tech, knowledge at work.
Today's robot rivals from Georgia Tech and Virginia Tech continue building on their soccer-playing robots. Let's see how the Hokies are doing on their wiring system.
This is a speed controller that allows us to digitally control the speed of the motor. It basically works by turning the motor on and off at a high frequency. To make the motor go slow, it would be on for, say, 10% of the time, and then to make it go its full speed, it would be on for 100% of the time.
Things on the Georgia Tech side have taken a turn for the worse. Miscommunication and changes in leadership are really starting to delay the process.
Was there a reason you decided to put the caster on the inside instead of the outside?
Oh, no, I meant to put it on the outside.
Oh, see, there's the problem. All we need is for you to be able to work on the launching system without the use of any of this.
Well, he needs a motor, though, I think.
Oh, the
what
motor.
I'm saying is we need to keep these bars off, let him work on this stuff, and just leave one on with a caster on it and start driving. Gosh dang it. No, but see what I'm saying? We've got a problem here, because you can't work on the launcher without, and we can't drive this at the same time.
Whatever we're going to do, we're going to need to decide quick.
Ah.
Yeah, you should have let Kyle do that. Left. That wasn't the way you're supposed to do it, did you?
In the restaurant business, this is what they call being in the weeds. You get yourself a little bit behind your schedule, you start to worry about time, and you start making big mistakes, start breaking pieces, start throwing wires around. Now what we've done is we've spent a lot of time, a lot more time than we expected to, making the drivetrain run. And we should have been driving it by now and concentrating on the launching mechanism, which we haven't. Now, since that didn't happen, now they actually joined the two parts together, and we've lost our modularity, which means now we can't build independent of each other. So then we're locked into the time frame of each team, so making us more in the weeds. So we're having fun.
We have our frame here coming together for our entire robot assembly. You've seen the two side pieces that we've been making out of these extruded aluminum rods here, and that holds our two motors together. Now we use more of that extruded aluminum to come across, where we're going to attach our ball shooting motor and wheel assembly.
Graham will connect the upright motor supports by attaching lengths of aluminum to the holes that Ian tapped earlier. Soccer playing robots, a fun but very competitive assignment. Well, guys, we're halfway through the day. How the team's doing, Brian?
Well, Georgia Tech, we had a pretty good solid plan at the beginning. We're going to do a modular approach. It fell apart a little bit, but they're really picking up the slack. They're going strong. I have no doubt they're really going to be rocking when it comes to competition.
So had little problems, but back together.
Back together.
Buzz, how's Virginia Tech doing?
Well, you know, Chris and Ian and Graham, those guys have really got a game plan together. They're working it, and we've already tested the kicker, so we know that part works. It's going to come together very quick, and I know it's going to be a very solid robot.
All right, Buzz, Brian, looks like we got some good stuff, and we got some, not so good stuff. But you know what? It doesn't matter. All that matters is the competition, and that will tell the final story.
Well, trying to put this scooper on the front here. So what my plan is just to put these bolts in here, and I can wedge this in between them and tighten the bolts down.
Well, since the sewing machine's so old, it doesn't have a lot of electronic parts that would be conducive of what we exactly wanted to do. So what we found is the last remaining electronic parts it had in it. We took a switch, which is a 3-pole switch, so I can turn on my controller with the switch and turn it back off. We found a wire, a connector, and another set of wires. And that's all we've used so far. We're planning on seeing if there's some other structural parts of this that we can use, and if we have time, we're going to try using some of these camshafts to make a flag wave, but I'm not promising anything yet.
See the test runs, trials, errors, and final moments of construction when we come back to Robot Rivals. Welcome back to Robot Rivals. Today we have two schools in the lab from Virginia Tech and Georgia Tech who were given the task of building robots that can play soccer. The team from Virginia Tech seems to be working smoothly, but Georgia Tech has had their share of difficulties. Let's check in.
Duct tape works wonder.
Finally, Georgia Tech has gotten their firing mechanism in shape. With a final adjustment of the chain, they're almost ready to fit it to the main drivetrain. It's their second attempt. Let's hope it works this time. Back over with Virginia Tech. Things are still running like clockwork. Chris and Buzz are working out the controller programming while Graham and Ian are finishing up the framework. The competition is coming up soon, so a test drive is definitely in order.
Georgia Tech has thrown some really interesting materials into their bot. Let's go check it out. Steven.
Oh, hey, Chris.
What's up with the duct tape? That's not too high-tech.
Well, it doesn't have to be too structurally sound, so we use duct tape instead. You know?
Well, what does this do?
Well, we're gonna have a little ramp here, okay? And the wheels are gonna turn and scoop up the ball.
Right.
And then this area is just gonna hold the ball until we later reverse the wheels and spin them out.
And that'll shoot it out.
Yeah. So this just has to hold the balls. It doesn't have to support any weight or anything like that.
All right, looks good.
Okay.
Except for the duct tape.
Yeah.
Duct tape or not, the soccer ball kicker is ready to once again be connected to the main drivetrain. Thankfully, everything fits this time, and Steven secures the aluminum bars to the wheels and motor framing with extruded connectors and 2-inch bolts.
There's two ways you can control a robot. Autonomously, that is to say with onboard programming, or with a radio control unit. I've been flying radio control airplanes since I was 13. And when I finally saved up enough money for my first radio, I went down into my shop, and like so many other shops, I had music playing on my normal AM and FM radio. And this is what I heard when I switched on my RC unit. What you're listening to is the digital signal that this transmitter is transmitting. Normally, a radio like this is tuned into a music station and is playing music. Well, right now, my transmitter is its music station, and that's digital music that it's listening to right now. Now, what does the radio system do with this digital signal? This is the other half of the radio control system. And here you have a receiver and an antenna. This is a receiver, and that's its antenna. But this is what this receiver does with this digital print. You can hear it changing, reconfiguring. This is like a voice print, a digital voice print, a picture. And every time I move these sticks, I reconfigure in some small way that digital picture. And as I do that, these servos reconfigure to whatever I'm doing on the sticks. Now, what do these servos do? I'll give you an example. Let's take a look at this radio control car. There's a servo right under here and it's connected to the steering linkage. The mechanical output. The digital signal is transformed into a mechanical output. For more information on radio control units, go to our website, DIYnet.com.
This is the code that Buzz just found for manual override of the speed controller with the trigger, so we can run it really fast forward. This is the kicker.
Let me explain what Chris is working on. Our teams are using the Isaac 32 radio control system. In order to direct their robots, they must enter lines of code into the computer. Each line gives the robot a specific command, such as moving forward, turning, and activating the soccer ball kicker. Once the coding is completed, it's then downloaded into the robot's onboard Parallax computer processor and receiver. This allows the teams to control all the functions with a single joystick. Finally, it looks like the Georgia Tech robot is ready for a test run.
We got it backwards.
Can you just switch the leads or something?
I can switch it in the program.
Unfortunately, they don't have too many minutes left to go. Let's hope they fix the problem in time.
I see we got wheels, we got duct tape. I told you about the duct tape.
Duct tape.
We got sprockets and chains and flashing lights. Are we ready?
We're about this close to being ready.
Well, we're about this close to the competition.
Well, then we're
all right.
okay.
Okay.
That's right.
All right.
Be done
Just
before it's
checking.
time.
Any day.
Practicing's for sissies anyway.
Well, we'll see if that practice time makes a difference in the competition.
All right. We're in the home stretch. We're almost there. Both bots are looking really good. It's anybody's bet who's going to win. The competition's just around the corner.
Virginia Tech continues to gain points by adding parts from the surprise household item. They've mounted the sewing machine's plastic exterior shell to the robot frame. It will serve as a harness for the switches, wiring, batteries, and speed controllers.
I don't know. There's a lot of small parts on a sewing machine. Would be really great for a lot of things. As for the size of our robot, I'm not real sure what we can use here.
It's a little late in the game to be worrying about the surprise household item. Maybe Kyle should be concentrating on getting his robot running properly.
Now I've already tested all the electronics. What we're doing is we're using the chassis of the sewing machine to mount everything. These right here are two main power switches. This one right here is going to turn the drive motors on and off. This one right here is going to turn the kicker on and off. Right now, we're working on trying to mount the speed controllers. These two will control the two drive wheels. And we got a third one of these right here that's going to go up there and control our kicker motor. And then we're using this little recess to contain our batteries so they don't go flopping around and flying all over the place. So we're getting together. We're having to add a couple of things hanging off of it so we can put our robot controller. But all in all, we're in good shape.
The Georgia Tech team has come to a familiar but unfortunate problem. Despite additional last-minute adjustments, the motors and controls still aren't working properly. If they don't figure out the problem, they may have a hard time controlling their robot in the competition. With only minutes before the end of the day, it's time both teams throw it into high gear. Virginia Tech, that's it.
Hey, what's up?
Georgia Tech, stop work. The day is done. Let's see what you guys have created.
Let's see what they got. Hey, Brian. Hey, duct tape. All right.
Is this what you got
duct tape?
Ooh, they did the same thing we did.
Oh, they put handles on it.
Yeah, I don't think it was doing the same thing. It's a structural piece of the...
Hey, that's nice.
It's all structural.
So are they
Wow, this thing is
ducks
huge.
with all the duct tape we got going on here?
Right.
You think they're using it?
I thought they were the Yellow Jackets. This is pretty cool. The ducks.
See, dude, that's what helps out to be an enemy.
Yeah. That's nice.
That's what I wanted, remember?
All right, now when we come back, the robot showdown will commence, so stay with us.
Today on Robot Rivals, we have two teams from Virginia Tech and Georgia Tech who were given the challenge to design and build a soccer-playing robot. After we introduced the surprise household item, a sewing machine, both schools jumped right into construction. Virginia Tech concentrated their efforts on using parts from the sewing machine, whereas Georgia Tech focused more on their drivetrain motor housing. It will be interesting to see what building approach prevails in our robo-soccer competition. I've dressed for the occasion and the teams are ready.
We've had a wild day here in the lab. Let's take a look and see how these bots came together.
Virginia Tech quickly laid out a design and got right to work. They tested the shooting mechanism and soccer ball holder, then moved to the aluminum frame assembly and added the motors and wheels. After taking apart the old sewing machine, they decided to use the connectors, wires, and gears. Then they mounted and tested all the power switches and programmed code into the onboard controller. Once the wiring, speed controllers, and batteries were added, it was time for a successful test drive. Finally, a laser pointer was attached for aiming. Georgia Tech started with half a design, then went straight into building the drivetrain and adding the wheels. Temporary casters were taped on while the shooting motor was mounted to the front along with rubber wheels to grab the ball. Miscommunication delayed work, but eventually the ball chucker was assembled and mounted to the original frame. Their first test went a little haywire, so they looked to the sewing machine for help in rewiring the controls. Another test got the robot working, but final adjustments still had to be made.
All right, guys, you ready for the match? Oh, yeah. Are you ready for the match? Yeah, all right, let's take a look at the rules and specifics for today's Robo-Soccer match.
Each team's robot will start at the center and must go back to their holding area to retrieve one soccer ball. Once the ball is contained, it must be driven back across the field and shot into the goal from outside the shooting line. Each goal counts for 1 point. The team with the most goals in 3 minutes wins today's challenge and advances to the next round.
All right, guys. You know the rules? You understand them?
Oh, yeah.
We're all ready to go?
Ready to go.
Almost.
Yeah.
No, not quite. There's one more thing. The surprise household item, remember that? Well, it turns out the guys from Virginia Tech used 12 items in their bot, where the guys from Georgia Tech only use 1. So what that means, these guys get a 10-second head start. So pay attention. On the first whistle, you guys go.
Got that?
On the second whistle, you guys go. And I also understand they've named their bots.
That's right.
From Virginia Tech, it's Mega Pele versus the Ramblin' Wreck from Georgia Tech. Yeah. Are you ready? Yeah. 1, 2.
And Virginia Tech is off and running, but going slow. It doesn't look like the 10-second advantage is going to help them. There goes Ramblin' Wreck. Georgia Tech is having problems controlling their robot. Look, Georgia Tech just knocked the ball into their own goal. Don't worry, that one won't help Virginia Tech.
All right.
Start sucking.
Up. Get it.
Oh, God.
Get it. There you go.
Virginia Tech has a ball now. And up. Ah, they missed it wide, real wide. Georgia Tech is trying to track down their ball, but the bot's still going wild.
There you go.
It's over here already.
Time to regroup and head back for a new ball.
Start sucking.
Get it.
Got it.
Got it.
Yeah.
Make this shot.
Georgia Tech is getting ready to shoot, and it goes wide.
Mega Pele's got a ball. He's going down the other end. Don't get taken out by this. By Ramblin' Wreck. Just aim it.
Virginia Tech shoots and scores.
Right down here.
All right, watch out.
Put another one in.
Stay away.
Georgia Tech is still having major control problems. It does not look good.
Let's go. Shoot another goal.
Woo! Yeah.
That ball.
Here we go. There's Virginia Tech is ready for another shot. And that's 2 for Virginia Tech.
Put another ball in. Let's do it. And suck it in.
All right.
Just do it.
Ramblin' Wreck is doing the shimmy over here.
There you go.
Yep, not much time to go.
But
Easy. Just calm down. All right.
Mega Pele is acting like Ramblin' Wreck there, but he's got his act back together.
Get it.
All right, now we got 10 seconds left. 10,
Shoot.
9.
Oh, yes!
Mega Pele got one more in. 5, 4, 3, 2, 1.
The final score is Virginia Tech 3, Georgia Tech 0. What a match.
Man, this is awesome.
Good job.
When we return, we'll hear reactions from both teams on the competition and their design approach throughout the day. Plus, we find out who Virginia Tech will be facing next on their mission to become the Robot Rivals champions. Welcome back to Robot Rivals. It's been an exciting day here in the lab as Virginia Tech and Georgia Tech were given one day to design and build a robot that could accomplish a series of tasks. When their time was up, we sent each school to their separate corners and geared up for our Robo-Soccer competition.
1, 2,
Both teams struggled early in the matchup, then Virginia Tech took the lead. Goal! Georgia Tech tried to rally back, but their robot, Ramblin' Wreck, would not cooperate.
Ramblin' Wreck is doing the shimmy over here.
And that's all Virginia Tech needed to put this challenge in the bag, scoring 2 more unanswered goals before the time ran out. Congratulations, Virginia Tech, on being our Robo Soccer champions and moving on to the 3rd round of tournament play.
Yeah, man, this was awesome.
Congratulations, man.
Good job.
Let's go first to Georgia Tech and hear about their robot building experience.
Georgia Tech, some things went right, some things went wrong.
Oh, I thought these guys did a great job. They had a lot of technical difficulties they had to overcome, and they worked hard. They did the best they could do, and it came out pretty good.
Yeah, no, and I came in on you guys. I mean, certain things, the drive system was going great. What went right, in your opinion, and what went wrong?
Well, you know, we came in with a pretty good design. It was the same as Virginia Tech, so I think we should expect that it could have at least had a potential to work. But we really ran down to that wire at the end. We didn't have a lot of time to test. When you don't test things, they don't work, so.
Well, it was doing a nice shimmy. I like that.
We tried to do our best, but we just didn't organize our time correctly. We ran around a lot at the start and a little miscommunication, which...
Yeah, I thought you guys had a good plan, the way you broke up your strategy, but it did go haywire somewhere.
Well, the important thing when you modularize is that you're both thinking the same idea, right? And we just kind of got off track here and there and lost track of the main idea we were going for, and I think that's what brought us down.
Yeah, all right, well, good luck, guys. You really did well. You had your problems, some glitches, and hopefully you can come back and join us for next season.
Yeah, hopefully.
All right. Okay, let's go see the winning team, Virginia Tech. Great job, guys, really. A clean machine. Your bot worked every bit as good as it looked. You guys want to make any victory statements?
All I can say is I am so impressed with these guys. We had a plan at the very beginning. They divided up, they executed, and we flat out conquered. These guys are fantastic.
We very effectively divided up and worked on each individual system, but in a way that it could be all at the end put together.
You know, I walked in on you guys many times, and it always seemed like everything was moving very smoothly. Is that how it went?
Pretty much, yeah.
Yeah.
At the beginning of the design, we had an idea, and we just followed through the whole time and put each piece together, and then it came.
Congratulations, you guys. You're one step closer to the championship and winning the coveted Engelberger Trophy. Let's take a look at who you're going to be facing next time.
Virginia Tech will be facing either Washington, Purdue, Clemson, or Utah, depending on who advances through the competitions.
All right, win or lose, guys. Come on, how much fun was this? On behalf of Buzz and Brian, Georgia Tech, Virginia Tech, thanks for joining us at Robot Rivals. We'll see you next time. Yeah! Hey, take a look at this. Yeah, right. That's it. He looks like a